Yeah, I think it's we're too many for introduction round. So what I want to talk is about how to use codification in Snap, and it's in Snap for a long time. And I have changed this a bit, so I have some kind of, yeah, I call it fake Python codification. So I will show you how to create Python code out of Snap. So that is the main part, and then see, okay, what can you learn from this and how can you use this in teaching computer science. So that is what I want to talk about. Any questions so far? Oh, okay. So there are two things which are driving me. One is that in experience in teaching is that if you move from blocks language to typing language, that's usually painful for the kids. And I've seen lots of kids which were enthusiastic about Snap and programming, and then they stop and lose interest. So this is why I'm interested in how to, in codification, how to move from blocks to a typing language. And the other reason driving me is that there is a German computer science competition, and there we need some kind of prototyping tool where we can build something, try out, tinker, and they later on provide or hand in something in Python. So this is also was driving me to find and work on something in Snap where you can create Python code. So this is what is driving me. To give you some background, I want to show you two slides about the German computer science competition, and what it's about, so you understand why I'm interested in this codification. So that is on the right side. You can see the exercise. It's called fill the ferry. So there's a queue of cars waiting for a ferry, like you see on the picture. And this ferry has 3 lanes, as you can see here below, and each lane has a limit of 20 meters. And all the cars waiting, they have a certain length, and you're provided with the list of the length. And the exercise in this competition is to develop some strategies, implement them in any programming languages, and discuss for which kind of waiting queues, what strategy is better. So you could say, okay, you fill every lane alternating. So the first car, that's what's on the picture here. So the first car goes to the first lane, second car to lanes 2, third car, third lane, and then you start again. That it goes then again to the first lane. So this could be a strategy that every lane is alternating. You also could fill the first lane until the first lane is full, all the 20 meters are full, then you go to lane 2, and then you go to lane 3. So the exercise is not only programming, but also discussed for certain length of certain with the use cases for queues of cars, what strategy fits better than the other. So that's a very simple one. A very simple of these exercises from this German computer science competition. And it's there we need some kind of environment to prototype something, to discuss, okay, we could have this strategy, and then what do you program, how does it look like, and then you say, okay, but then you also need some additional. And if you're not really good in Python then, or in any typing language, then I was looking for some kind of environment to prototype something, build something, and discuss. So that was also driving me to look into this codification. Okay, so now I would like to show you what the codification in Snap is and what it does, because there is something for a long time. So there is something what I call here legacy codification, because it's there for a long time. And then I would like to show you how what I've built, or what we've built for teaching purposes, what we call fake Python codification. Okay, there's this legacy codification. I will demo in a second. So you have to switch on in Snap. What you can see on the top, on the right side, you tick the codification. And then, I mean, it means that you write a program in Snap with Snap blocks. Like you can see here on the bottom, on the left, here, please enter number. And then if it's bigger than 2, then you get numbers big, other numbers small. And then this is, then you have a mapping, which you see on the right. Here it's mapped to Python. So the string is mapped, the delimiter, and then all these blocks are mapped to some kind of code. So you can see the if is mapped to if, #1 and then #2. So codification means you have some kind of mapping. And then in the end, you get in a variable, in the variable code, you get this code which has been generated automatically from this Python code on the left. So that is there, and that is what, I just want to show you. So can you see the screen? Well, I guess you can see the screen. Nobody complains. So this is now, or let's go just to show you. You can see here, open the project. So it is already an example for codification. And then you can see here is the example code. I'm just thinking to make it a little bit bigger. Zoom blocks 1.4. So that is here the example code. And then you can see here at the bottom, there are here 4 languages. So as for example, here, I take here this one, mapped to Python. And then behind it, you find the mapping of certain blocks to certain code elements. And if you then want to create code for JavaScript, you could click here on JavaScript, you could click on Smalltalk, or here on Python. And then if you export it, you get here some the Python code. And you can see already here that's Python 2, so it's already a bit old, no? Right now, since I think 5 years, there's Python 3. So this is what I call the legacy codification. And what you also can do is, how does it work? Okay, sorry. How does it work? So you have a certain code here on the left. There's some blocks. And then you can see how this mapping is, in the end, it's purely text substitution, is then block by block following the sequence, how the blocks are put together. And in the end, you get here, as you can see on the right, the Python code. So, and that is what I also want to show. So it's not only single blocks, you also can have functions. So you have a possibility to have, to map a header and a code. So if I have here on the left my function with a parameter, then this is mapped to a function to the header. Then here on the bottom, if I use this function I defined in Python, here my function with a parameter, then this also is within my Python code, is then with the code, my function, then the function is called, is then mapped and created in the my Python text. So I even can do recursion and lots of complicated things. Even also higher order function. I will show them also later on. So, but this is now what I wanted to show you in the, I call it legacy codification. So there's an option to create legacy, to create Python code out of Snap blocks. So any questions to this so far? Okay, then I would continue. So what are the issues? No? So when I looked into this, I thought, yeah, that's nice, but what are the problems with this? So the first is that the languages and the blocks, they feel very differently when you touch it, because there's a different vocabulary. The vocabulary is different in the languages. So here on the right, you can see on top, this is the native Python blocks, snap blocks. So you have a list, and then you go through for one to the length of the list, you say the item of the list. This is standard. But here, one below, you see the list, and then you go for I to the range of between 0 and the length of the list. Then you go to print list, and this is then closer to the Python code, as you see on the bottom. I mean, this translates more or less 1-to-1. Yeah, and one example is that if you do things in Python, you get used to have this range keyword which creates for your list, either starting with 0, or here if you have 2 parameters, 12 to 19, it starts with 12. Or if you have 3 parameters, then the third parameter is the step. So that is something you get used to if you work with Python. And then, of course, if you switch between these two environments, you're missing this. And it feels different if you have the standard snap blocks and you don't have the blocks which you're used to. Also, if you want to move from snap to Python, of course, it's also an advantage if you're used to the thinking in this. So that's something, I don't know how to call it. It's the feel, it feels differently. The languages are differently. And then if you talk about lists and strings, then in Python, lists and strings start at 0, but not as 1 as in snap. That's also what you can see in these codes examples here on the top right. So in snap, you always would start with 1, but in Python, if you have a list, you would start with 0. So also as you can see here in the real Python code. So if you have this list here of ASD, the 3 characters ASD, so you would start with 0 and then print this list. So that is just the starting point, how to the index of lists is one point. The other one, other points, there's several ones, is Python doesn't really differentiate between lists and strings. So in Snap, you have for lists, you have the red color for creating lists, and for strings, you usually have green ones. So lists and strings in Python. So when you get into just play around with codification, the legacy codification, you quickly understand that you have to have a trade-off for what language do you really implement. So if you have, if you stick with lists, in standard, then snap, then you start with 1. And then of course you have to change the code you created, the Python code you created. So there are lots of issues with mismatches between the languages because the languages don't match 1-to-1. So, and that is then where we started to build our own blocks, which behave more or less like Python blocks. So you can see here you have an assignment, which is just the assignment operator. You have print and input. Here this input, for example, in Python returns a string all the time, always. So you can see input, please enter number. So this is assigned, or the return of this input is then assigned to this input string. And then you create with the int keyword out of the string a number, and then you can continue like this. So what you can see here is that you have a snap program, and this translates 1-to-1 to a Python code, and it also feels, I don't know if this is a good word, feels like Python if you see that, because you see the words and you see the syntax like this colon here behind if. exactly as you see it here in Python. So that is what we have built and started to create blocks, which we call then fake Python blocks, because it's not Python, it's Snap, but they feel and behave exactly like Python blocks. And the purpose is to, yeah, as I said, to create Python code which runs without changing anything, without running directly out of after creating the code. So you can see here on the bottom on the right, please enter number. Number is here it's 23, number is big. And then you can see also here print, this is a list. This is then the output in Python, this is the list. And if you use this join, which creates out of a list, a string, then you can see here that is then the output. This is a list. So this now feels exactly like yeah, as Python. So any questions so far to this?
Yeah, I was wondering, is, you know, the way Snap treats numbers and strings the same, if you didn't have the int there, you just said number was equal to input string, the program would work in Snap but not in Python, is it right?
Correct. I mean, that is one of the first things I had about 4 months ago, that yeah, that there was, it was a character. No, it was a character, and I was wondering why did the program behave so strange? No, because here the number is, or this int in Python creates a number, but in Snap exactly it doesn't do this. No, and then of course the program works in Snap, but in Python it works differently. No, it's exactly right. No, so that was one of the reasons why we created this int block, which creates, and in the end, it's a bit fake, like everything, creates a number which in the end in Snap already is a number. Yeah.
I have also a question about the fake blocks. Can you, so once you start doing the fake blocks in Snap, you cannot mix and match with real Snap blocks? Like instead of an if, elif, else, could you put in an if and an else of Snap?
Sorry, I don't get the question. What's the question?
Yeah, I'm saying in your example here, you have an if block with a colon at the end and an elif with a colon and so on. Right? Can I replace that with a regular Snap if else?
Yeah, I mean, you could. It also would work, of course. And then if you have in the mapping, let me show this. Where is this? Here. So I just want to make it bigger. Here you have this block, and if this would be then part of your mapping, then you could mix these blocks, the fake Python blocks and the real Snap blocks, you can mix it. That's not a problem. You can see here there is an if, that's that's a fake block, I think. I even don't know. No, that's a real one. That's a real Snap block, and you could combine that. I mean, that is then, is this here? Oh, sorry. Yeah, here, that's a fake one, no?
Right.
That fake one, yeah. But you could mix it. It depends if you include it in the mapping, it works. And then sometimes, of course, you have to decide, sometimes not a problem because it works exactly the same, like this one, for example. I mean, here you don't, here would have a colon, if it would be Python, but I mean, it works. No?
Okay, so the way you think of introducing this to students is you start with pure snap blocks and then you transition to fake snap blocks and then you do the Python. I mean, how do you see the progression for students happening?
I will come to this later.
Okay, thank you.
Okay. Okay, so now 2 more slides about the look and feel and why we're doing this. So here you can see that in Python, you would have, as here on the right, you can see, you can, if you try to, how do you say, to access in a string or in a list an element, you have these brackets and then you have an index in there. So you have here, for example, on the right, you see text of 2. The text is snap is cool, text of 2, and that gives you the A. So 0, 1, 2, 2 is the A. No? So, but what you also have in Python is that you can also, and that's the red one here, you can read the elements with a negative index from the end. So if you have text of -2, then this would give you the L. So this is different. That's one of the things which is different. And the other thing which is different, what you can also see at the bottom is that you have strings and you have lists, and these operations to access a list or a string work the same. So here you have on the right, you have a list with, this is a list, and then you have list index 2, and then you get the A. Here and here you have a string, or the variable is a name text, doesn't matter. So this is what makes it feel more like Python, or this has works exactly as Python. And then you have here only one parameter, and what you also have in Python, and that is of course important when you go through lists and strings and data structures, that you can have also 2 parameters, and that means you start, here you have a from and a to. So you start somewhere and you go somewhere. So here in this example, text 2, then you have would start at the 3rd element, app is cool. And or if you have only from the end, then you would have only until the first 2. Then you would have this one. So this is also where Snap and Python are very, very different, and where we have built these blocks so they work exactly as in Python, and they also work for strings and lists. So now I want to go back and show you why we're doing this. This is now from the beginning, this computer science competition. If I get there, cancel. So let's see. So here you have now this cube, and then you see the cars here. Then they are put to these lanes by random, and then you can see here how the lanes are filled. And here you can see then the length of the lane. No? So the whole queue is here in the end. Let me just do that once more before we go to the code. So there's a queue of the waiting cars and the lorry and for the ferry, and then the 3 lanes are filled by random. So now if we go to the code, you can see here, this is here the code. And this is then, of course, a bit longer. And now I want to show you, and now all of the, I think most of them of these blocks are fake blocks, no? And some of them are easy, like this one, because this just creates a list, and some of them where you have to take a lot of options into account, then are more complicated. So now I take this one here and put this to list bright, and then put it here. So and then see the code. So, and now you see here the code. I export it. So, and this is not how, of course, now a bit of showing off and bragging. Where is Python? Here. Paste. So, and now you can see here, this is how this code worked. And this is now, as you can see, I go back now to here, the demo. This is now what the code on the right is, then what I created out of these Python, out of these snap codes. Now, and you can see that even some higher order function like reduce, which takes this ladder, is part of this here. And you also can see that, it's something you can see here, that here you have this lane visual. This is visualizing the cars. And that is something which, since for this function, it's not part of it, it's just skipped. So it's not stopping it, it's just skipped. But what you see is then here on the right is the code which has been created out of this. So yeah, there are only just a few more slides. So the way what we're doing is that we have here on the right, left, you can see we have the standard blocks, then we have our 5 Python blocks, and then we are creating programs based out of this Python blocks. So here on the right, you can see we have 2 phases of programming. So we are programming in Snap and tinker around and try and see. And once it's fully understood and we know what we're doing, then we are moving to Python. No? And that was one of the things for this computer science competition where we were looking for something. So we have something the 13, 14, 15-year-old kids feel comfortable and can build something fast, which would be in Python, not with the speed, because they're not that good yet. They don't feel so comfortable with it. And they would not be able to build something so fast in Python. No? So that is then why we have then these 2 phases. Any questions so far? Because I'm coming. Yeah.
I have a question.
Yeah, cool.
I think this is a really cool project. 2 questions. Did you consider, with what you call text, did you consider calling that string?
That was, so it's
You probably lost sleep over it, I was wondering.
that was probably, did you mean this here? Did you mean here the text?
Well,
String, that's just the name of a variable, and it was just, you're right, it would be nice if it's called string,
that might be nice, because, introduce them to the concept of string. And
that was, it's just the name of a variable, and it was,
so my other question, this might be jumping ahead a bit. I think this is great. When I explored using Snap to transition students to either Java or Python, I kind of hit a roadblock when I saw how Snap viewed objects. And so I wonder if you've gotten to that point of how to transition students from.
What do you mean with objects? Do you mean classes and object-oriented programming, or what do you mean?
Yeah, like I had thought maybe the sprites, and I think sprite is what Snap uses. I know Scratch uses the word sprite, but that concept of like a sprite could be viewed as an object with state and methods or functions. But it sounds like you're mostly dealing with the imperative aspects.
Correct. As of now, that is what you can see here. Maybe is so. Yeah, let's put it like this. I'm proud that I made it to the higher order functions.
Really,
They
it's
are
awesome.
included, but I don't have. I have not thought about what to do with objects.
Okay.
And classes. And I mean, on the last SnapCon a year ago, then I was doing actually classes and objects and trying, okay, how does it link to Java? No? So, but that is what we haven't done in Python so far.
Yeah, I mean, what you've done is amazing already. And I think people will want to know when they can use it, if there's a horizon.
Yeah, that is also how I was thinking when I was preparing this. The problem is a bit, if you look at the blocks, that, as you can see here, everything is a bit quick and dirty. That's the first one. Sometimes, let's see, there's something else. There's also explanations behind it. Here, for example, where, so it would need a good cleanup, no?
Yeah. Before
providing it. And then there's also, because, yeah, where is this? I think here, is it here? No, yeah, but it's not in a state that I would like to, yeah, to, you know, throw it out, no?
Yeah. Okay, thank you for answering my questions.
Yeah, okay. Any more questions?
Yeah, I was wondering if you thought about more of a hybrid approach. When you first started talking about how, you know, range and for and the indexing 0 and 1, I kept thinking, well, there's higher order ways of writing these things. We're using map and for each, and they're kind of make a more straightforward bridge between Snap and Python if you ignore things like for loops, but you go with the higher level things like map and for each. I mean, obviously it's not going to be a perfect one-to-one mapping, but at least if somebody has gotten very good at Snap, then they don't have to sort of learn fake Python. They just sort of learn that if they use the higher order level of it, that it maps pretty straightforwardly to Python, I would think, but maybe not. So I just wonder if you thought about that.
Yeah, in Python, I mean, in Snap, you have all kinds of control, yeah, blocks and structures. And actually in Python, you have only two. So you can go through the list via the index and
I have a doubt.
Sorry?
I have a doubt. So when I am seeing in Snap, there isn't a library as codification.
Yes, there is a library called Codification, which you can see here. There's a codification support. But the blocks you can see here on the right, they're not part of any library. They are more or less handmade. And this is here just one example, which looks pretty ugly. Just here, if, elif, else, no? So,
Okay,
but it's
thanks.
not a library, it's not in the library. So this is just a program.
Okay, sir, thanks.
Okay. Okay, but I think it was Ken. The question was, okay, first of all, you can mix it. You can mix the coding blocks, the loop blocks and the Python blocks. It just then doesn't look so one-to-one anymore. And you can see, I hope you can see, you have, we have here the higher order functions. And there's also something where I realized the higher order functions are much nicer to get used to in Snap. So also when if you have a map, for example, here this map, it's much more straightforward, and you learn it much quicker in Snap than in Python, as in much more snapper in Snap as in Python. So, but I'm not sure if this answers your question.
No, it partially does. I guess I was really thinking you answered part of it, but the other half of it is sort of maybe the pedagogic question, which is whether you think, at least in some contexts, an alternative would be that you let the students become very good at Snap, and then you teach them that if they do use things like map and combine and some of the higher order things of Snap, then you show the codification and what the equivalent is in Python, so that they've already understood the concepts in Snap. And as you said, some of them are easier to learn. And then, I see a value to both approaches to sort of learning Snap and learning Python. But I'm thinking, my preference, I think, would be that encourage students to really learn Snap very well. And then if they use the sort of higher order piece of Snap, that the translation to Python is kind of clearer in some ways.
Yeah, I mean, this is not something for Snap beginners who are 9 or 10 years old, no? So to build, I mean, to build something like this probing here for the ferry, there you already can see that you're getting to the limits of the screen. So and to build this or to understand this, what's going on here in this this program, that is for advanced Snap students. Let's put it like this, of course, no. I think it only makes also sense to discuss or to build this if the students have already, or if you as a teacher or the students have Python in mind, and they know that they're doing this now also to move to Python. No? It's not, I don't think it makes sense to use it to teach ordinary Snap programs and build them. Okay, so, but then I would like to quickly finalize this, what I wanted to discuss. So what I found is, first, that I learned more by building these fake Python blocks than learning Python about this building Snap blocks than I did by learning Python directly from some books. But also what I realized more and more, that Snap is more lively, more visual, more intuitive than Python. I mean, if you just click on a variable, like here you can see on the right, this ferry, you see right away how much elements does this list have, how much what is in the list. So to visualize something comes by Snap automatically. And then if you look at the bottom here, where you only see lists of numbers, that is it's more abstract, and you really have to understand, you have to create all these visualizations by yourself. So I realize, I mean, you also can discuss really complicated algorithms in Snap. So I think it's more useful to postpone any typing language as long as possible, because you can use Snap, and if you haven't understood it in Snap, then you won't understand it in Python. So and also in the last one, I mean, if you get familiar with using these fake Python blocks to build something, it eases also down to when you move to Python, because you already know certain blocks like this range, for example, which gives you a list. It's the feeling between then Snap and Python and move to Python is then faster. And also there's an example here you can see, if you're iterating through a list, you can actually do this, that you either use there for each element, or that you go by an index. That's something which you, I mean, in Snap you can see right away if you click on the variable. And that is also something where you have in Snap, you have two colors, and this coloring shows you, okay, once you're going by the index and you have just a number and take the numbers to go through the index and then take the element by the index, or you go for each element. No? That is, you go for each element, and that's also something, just another example where you more quickly understand something by using these blocks, which you wouldn't understand so easy by the coloring. If you start right away in Snap. No, that is also something. Yeah, where what we've seen, yeah, or I've seen the last half year. So, and now I just want to go through my last slide, yeah, to have some, yeah, discussion about it. What you think, is it worth it? Because for me it was fun to build all these blocks, but I also always was thinking, is it really worth it to put all this work in there, in these fake Python blocks? Is it worth it? Does it really help you to understand, to learn the students to understand something faster, to learn Python faster? Or is it just a tech gimmick with no value? This is what I was thinking the last half year quite often when I was building these blocks. Does it really accelerate to have it or not? Because so far we have only limited experience with really using this in teaching, these codification with to move to Python. I mean, most of this has been built the last half year. Yeah, and this is where we will try out when we are preparing, for example, for this computer science competition. We will try this out and see this, but this would be now the last 50 minutes. If you have questions or if you show something to discuss this. Thinking the last half year, is there really value? Does it really help to understand faster? And I'm not convinced yet. I don't have a, how do you say, I'm not convinced that 100% that it's really useful because I haven't tried it out that much. No?
I think it's promising. I think some of the examples that you've shown illustrate some of the stumbling blocks I've seen with students at the college level and the high school level, like the whole idea of range, iterating through using an index or the values, you know, the elements, and just that syntax with the colons and the spacing and all that. So to me, it looks promising.
Okay.
I have a different question. Have you thought about, or do you know of anybody that's tried doing anything similar with JavaScript? Whether,
no,
don't know, have you thought at all whether it'd be harder or easier? Or?
No, I took Python because it was the language to teach. No, for men, that was just coming from this competition that we thought, okay, we use Python. But in principle, I think, I mean, after doing this for now, for building a lot of blocks in this, you can see here, there is a big overview. No, there's also, I mean, that's here for rand and also rounding and combining true and false and all these things. I think you can do this also for JavaScript and also get really to the level where 90% of the most important JavaScript blobs or so work exactly as in JavaScript. I mean, I found that the Snap is really flexible and versatile, and you really can build a lot also with this option to have this header and the code. I was struggling in the beginning. I was struggling a bit with the higher order functions because here you have to put in the variable, but also here, I mean, this map and this range translates one-to-one perfectly to Python. So I don't think this JavaScript would work. I think it would work the same way. But it's work. It's not. It doesn't come for free. I mean, you really have to. You have to do a lot of coding, so the blocks work exactly the same. No. And if you see here, for example, yes, the slicing, especially here, it still says work in progress. Just to show you that is one of the more complicated things. You can see this is a long code, no? Because you first have to see what kind of, is it a text, is it a string, is it a list or not? Then you have to build up the result out of the numbers in here. So yeah, it's work.
I mean, it strikes me as being helpful for teachers too, because we're in a situation where a lot of teachers are put in a situation of teaching computer science when they're just learning it themselves. And if they make that leap to even to a block-based language, this can help them transition to a text-based language like Python.
Yeah. Okay, somebody says my class.
Okay, so go ahead. You have time for another question?
Yeah, sure. We have 10 minutes left. Yeah.
Yeah. Because it occurred to me that it would be interesting to go straight to fake Python, never show them snap, and see if it's a better way.
I'm not sure if Jens,
if you're intending to learn Python, at least you've got the fact that you got the palettes, the syntax, you know, there's some value, of course, to doing it in a blocks way. And it'd be interesting to know whether the students kind of more quickly picked up Python if they had fake Python first, but not learning snap before that.
Yeah. Yeah, I mean, you can, I haven't shown that. I mean, you can see here on the right, on the left, you can, in Snap, you can show the primitives, then you see everything, but you also can hide the primitives, and then you would see only the fake Python. So you can see here for the input, that it's only, or for sensing here, and sensing there's only input. For looks, it's similar. There is only, yeah, print, or here that is something for printing a whole, yeah, forget it, for Spalte, no? So for motion, for example, I think there shouldn't be anything. This is not for me, there's only, yeah, from turtles. Yeah, this was just for turtle for some experiment. Sound, of course, is nothing, but of course here in the, here, these are all fake Python blocks. No? So there are lots, and there's some garbage in there. So, but you can, I think the difference between Snap and fake Python is not that big. I mean, and you can easily switch here between both of them.
Yeah, I think if the goal is to learn Python, for some audiences, it may be easier to start with fake Python.
Yeah, yeah. Okay. Yeah, somebody wrote in the chat that it's similar what Microsoft is doing with MakeCode, which I haven't seen. I've seen something from Apple with Swift or something where you have on one side blocks and on the other side text. Yeah, I mean, it is, I guess it is something similar. I don't know really, I don't just know this make code, no? But.
Yeah, I have a question. What, as you're developing this system, what language are you using to write all this?
Oh, this is nothing else. This is only Python, only Snap.
Only Snap, okay.
There's only there's nothing special behind it. There is, here you can see on the left, I'm just using the standard blocks. We're using the standard blocks, and then out of the standard blocks, we're building these fake Python blocks.
Mm-hmm.
So there is not this, it's kind of Snap in Snap. No? This is why we have these 3 levels. And then out of this, we build our fake Python programs. And this is why I'm hesitating to share all of this, because if you're building these fake Python blocks and it doesn't work 100%, then you're in big trouble if you're not really good in Snap. No? So, so the quality level is so far of the fake Python block is not that high. So, but there is nothing, it's nothing special. There's no, I haven't done any JavaScript. I haven't done any JavaScript. I mean, even the higher order functions is just, I just want to show you higher order functions, is almost exactly the same as, yeah, it's just a cover, no? Here you can see the map. I only have the map lambda and x, so because that is what you would have in Python. So it's just some syntax. No? So it feels a bit more familiar, but then I'm just using map the functions over the list.
Okay.
And just going back to, I think it's a good, if you build this, all of this, you really learn a lot. No, you can see that for here, for example, that you have a function over a list. No, and then this map needs a function. So you learn a lot about when you're building all of this. No.
Mm.
Okay, then. Yeah, it highlights how many difficult initial concepts for me in programming language are simplified by block coding. This is by Mr. Stempel. That is true. That is also when we were building this, we realized it is so intuitive because of this and this. But now that we are rebuilding it, we see how it really works. No? So, for example, that if you put a block in an if block, that what you don't have here, that this is an action, and that, you don't see this here, that is something I was not so aware. I mean, it's so intuitive that you just put a block in here, but here if then else. But if you see, you have a Boolean, you have a block, you have a block, an action, another action, and then you are just running this action. So that is, I mean, it's actually, it's not Snap, it's coming from Scratch, and Scratch has, yeah, some, how you say, brilliant ideas on how to make it easier to understand. Okay, so, okay, then I think it's now time. Then, yeah, thanks a lot for joining by. Yeah, I think this is recorded anyway, so I will share some, how do you say, some version that you can, yeah, take a look at, but then there's no guarantee from my side that everything works. No?
Thank you.
Okay, thank you. Yeah, bye.